Good afternoon, ladies and gentlemen. This is for people who want to do or a little bit of guidance around activity number 5 in our book, which is modelling reactions. Might be useful for the for some of the netball girls. What we've got here is the diagrams represent various molecules, which are the products or reactants in an equation. Now, the first thing that you need to do is to identify what each of the symbols represent, and you can do that by reading the equations down below. So our first one is burning carbon in air to form carbon dioxide. So we've got carbon and air on one side and carbon dioxide on the other side. So of course, because it's mentioned carbon first, the coloured in one here must be carbon. So we add carbon there. Okay, and obviously if that's the dioxide, di means 2, these ones here must be the oxygen. Okay, so again we've got oxygen there, we know of already. We've got combining sulfur, we've got the D, so end up with going with sulfur. Okay, we're burning hydrogen to form water. Okay, so our crosses there must be hydrogen, and you simply work your way through each of those until you find out what you've got. Okay, so obviously working our way down, the circle is forming carbon tetrachloride by reacting carbon and chlorine gas. Well, we know that carbon is the colored one, so therefore just the circle with the donut, I suppose, is going to be chlorine. Okay. Up here we've got ammonia, which is NH3, so we've got 3 hydrogens there, so our X1, that must be our nitrogen. And then finally we've got our X1 here, which is burning magnesium in air. Okay, so our X must be magnesium, and then that leaves copper carbonate, which is CuCO3. We know the carbon here is the coloured one, so therefore that must be the copper there. Okay, and that's essentially the first thing that you do. Then you need to try and put the appropriate symbols to represent either the products or the reactants. Now, just remembering, if it's a gas, so chlorine, oxygen, chlorine, oxygen, nitrogen, hydrogen, all will all have 2 atoms per molecule. Okay, so oxygen is O2. Okay, hydrogen, H2. If it's nitrogen gas, then it's N2. If it's chlorine, it's Cl2. Okay, so that makes that. So now we need to put 1 molecule of oxygen here. So that's our 2 triangles joined up, and then we need to count to make sure that they're the same on either side. Okay, so we've got 1 carbon, 1 carbon, 2 carbons, 2 carbons, so tick, that one is all done. If we're combining sulfur to form sulfur dioxide, so again we've got the sulfur and we've got our 2 triangles either side for sulfur dioxide. Okay, now over here is an interesting one because we've got burning hydrogen to form water. Okay, so that's 1 water molecule, but you'll notice we've got 4 molecules of hydrogen there, so we need more molecules of hydrogen over here. Now you can't just put hydrogen over here because it says burning hydrogen to form water, so we can only put down water, so we need another water molecule. So we would write another water molecule there. But of course, if we're burning it, it means we're burning it in air, and we need O2 for that to happen. So again, we count them off: 4 and 4 hydrogens, 2 oxygens, and 2 oxygens. So that one's pretty cool. If you want to go ahead and have a go at 4 to 8 yourself, you can stop the video here, then you can come back and check to see if you've got the right answers. Okay, hopefully you're finished. So we've got reacting sulfur and hydrogen to form dihydrogen sulfide. Okay, and we can go here like so. That's rotten egg gas. Oh, sorry, rotten egg gas. And if we do rotten egg gas here in the building, we've got to evacuate the whole building. Now, if we're reacting hydrogen gas and nitrogen gas to form ammonia, we know that nitrogen gas is going to be 2 pluses. We've got 2 pluses there and only 1 there. So we need another molecule of ammonia. And then we've got 6 hydrogens on this side and 6 on that side, and 2 and 2. Now, copper carbonate's an interesting one. I could put a little triangle there, which doesn't actually represent oxide, it represents heat. So if we just heat it up, only one reactant, just heat it up, it'll break down by itself. And it breaks down into carbon dioxide, so we know what carbon dioxide is, okay? Because we've done carbon dioxide in the past, so we could go there, okay? And then copper oxide, which is copper and oxygen together. So, and again, we count them up: 1, 2, 3, 1, 2, 3, 1, 1, 1, 1. So that's cool. Burning magnesium in air to form magnesium oxide. Well, we do know that air is contains oxygen gas, which is O2. So therefore we need 2 oxygen gases on this side. So therefore we can add another piece of magnesium oxide, and then of course we've got 2 oxygens and 2 oxygens, but we've only got well, we've got 2 magnesiums here, but only 1 there. So it goes like that. And of course, carbon tetrachloride, which is liquid paper, which became the tape over the years. You react carbon and chlorine gas, where you've got 1 carbon there, 1 carbon there. You've got 2 carbons and 4 carbons, so you need another chlorine there. Okay, and that's essentially the same way as you would do, when you're balancing equations. It's the law of conservation of mass and matter, which means you need to have the same number that you start with is what you need to finish with, and the same elements as well. So again, judging by what the equation says, that's what you're going to be left with. So hopefully, ladies and gentlemen, that is going to be helpful to you. Thank you for tuning in, and have yourself a most wonderful day.